Duck typing. This is fun. So, I keep saying, right? Ruby emphasizes what do you do, what methods do you respond to, instead of emphasizing what class are you. So the question is, why should you care about this, right? How does this encourage productivity? What kinds of reuse does it buy you? So an informal and humorous name some people have used to refer to Ruby's implementation of this is duck typing. And you may have heard the colloquial expression that if it looks like a duck, it walks like a duck, quacks like a duck, well, might as well treat it like a duck. So what we're saying is if you have an object that responds to certain kinds of methods, you just should treat it as the thing that it looks like it is. If it responds to things like give me each of yourself or reverse yourself, well, what is it meaningful to talk about those operations on? Well, it must be some kind of a collection. So you say something quacks like a collection in Ruby, it means, you can expect that thing to respond to most of the same collection-oriented methods that a normal collection, like a built-in collection arrays, would respond to. So if you've used interfaces in Java, you'll notice that this is kind of similar, but I think this is actually much easier to use. Whoops, sorry. So as an example, if I call sort on my list, what does that actually mean? Well, suppose my list is something like this array of integers. You can imagine what it would mean for sort to operate on that. What if it was a list of strings? You can imagine for what it means for sort to operate on that. Or even a list of symbols. Or even what you get back from I/O read lines, which is all of the lines in a file one line at a time, right? This last one is basically a way of saying sort this file. So why does this work? To get the answer to the question, we'll introduce one new Ruby construct that doesn't really appear in other languages. And in languages where it does appear, the term module doesn't mean the same thing. In Ruby, a module is a collection of methods that aren't a class. So you can't instantiate it. There are no instances of a module. It's really just a group of methods that collect a bunch of related behaviors and they go together. Now in some simple cases, the use of a module is just to collect methods like methods related to a common set of operations, like mathematical operations or constants that are mathematical operations. That's pretty trivial. The much more interesting use of modules, which we focus on, is when you use a module to mix methods into a class. So what does that mean? Suppose that in my declaration for class A, I say include the name of some module. That means that when I try to call a method on an instance of A, if I call, for example, a.foo, first it will search whether class A has that method. Then it'll search whether any modules included into the class have that method. And then it'll do the other stuff we've already talked about. It'll call method missing. It'll punt up to the ancestors. But modules essentially give you a way to say, wait a minute, add a few things to this class. I'm not done with it yet. And the reason you'd want to do that is that it's often possible, because Ruby cares more about responding than it does about classes and types, it's possible to define modules, collections of behaviors, in a way that's reusable around a lot of different classes. So in fact, it might surprise you to learn, as one example, that the sort method we used on the previous slide as an example, you'd think that it's defined on arrays, but it's actually not defined on arrays. It's defined in a module called enumerable, and the enumerable module can be mixed into any class that knows how to enumerate the elements of itself. Let me say that again, because this is a little bit non-obvious, okay? We saw these different examples of using each, and I kept saying, we're not intrusively reaching into a collection and getting stuff. We are asking the collection nicely, please give me back each element of yourself in turn. I don't care how you get them, I just want each element so that I can do stuff to it. Now what we're saying is, well, if you can do that, then there's a bunch of things that I know how to do for free. For example, if you can return each element of yourself, I can sort you. Right? Provided that your method, the things inside your collection are in fact sortable. We'll come back to that in a moment. What else could you do? If you can return every element of yourself, I can test every element against some condition. That was select and collect and those methods that we saw. So what does this mean? As a concrete example, it means that a mix-in is like a contract. The module enumerable, we're going to use as an example because it's used all over the place in Ruby. It's very common. It assumes that the target object and the class you're mixing it into know how to respond to each. Right? So like I said, if you define a new class, for example, a binary tree data structure, and you define each as a way to get at the elements of that data structure, you can now mix in enumerable, and you'll get these methods for free. It will define for you predicates like all and any, collect, find, include, map, partition, a whole bunch of really neat stuff just because you agree to provide each. This is a hugely powerful behavior. Enumerable is also where sort happens to be defined in Ruby, but sort also has another requirement, which is that your sorry. Sort also has another requirement, which is that the class, the elements in the collection be able to respond to the spaceship operator. Remember the spaceship operator? It's kind of rolling all the equality operators into one. A spaceship B is -1 if A is less than B, +1 if B is greater than A, -1 if A is less than B, +1 if A is greater than B, and 0 if they're equal, right? And you can imagine for whatever class you want, you can define the spaceship operator. You can define it to be sorting your colors in your favorite order if you wanted. Now, obviously, in classes like int and string, spaceship is already defined with the semantics that you would expect. But the important thing about this is if you have a collection of things and the collection responds to each, and if the elements in the collection respond to spaceship, then you have to do 0 work to get that thing to be sorted, right? Because what is sorting? It's taking pairwise comparisons and seeing which one is greater of the two, and in some algorithmic form, putting those things back together. And in fact, there's another module that ships with Ruby called comparable, which says if you provide the spaceship operator, which takes one argument, right? Spaceship takes one argument because there's the receiver of spaceship, and there's the thing you're comparing the receiver against. If you provide spaceship, then I will define these other ones for you. And I'll also give you happy ones like between, which tells you if one element is between two others according to sort order. So what does this all mean? It means the class of objects really doesn't matter, almost at all. Only the methods to which they respond. Let's look at a couple of concrete examples of this. Sorting a file. Well, we have file.open. That's a method that returns an I/O object representing an open file. And if I/O objects actually define each. They define it as, I'm going to return each line of the file in turn. That's a pretty sensible semantics for reading a text file. So what does that mean? I can say open a file and sort it. That's it. I don't have to provide anything because the thing that I'm calling sort on is a collection that responds to each. It knows how to yield every element of itself. And inside that collection, what is each element? Well, it's a string, right? It's a line of a file. Strings know how to compare themselves. That's part of the built-in string behavior. So with no extra work, I can reuse behaviors despite the fact that the classes are different. I can also say, which lines of this file begin with a vowel? Well, that's easy enough. We already know how to use select to pass an anonymous method to something, anonymous function. So for every line of a file, we're going to pick out the ones where this regular expression match returns true. Again, 0 additional work. We can do our own example with accounts, but before we do that, let's ask how it would be done. So if I define, here I've got 3 savings accounts that I've initialized with 3 different balances, and suppose I try to put those 3 savings accounts into an array and I try to call sort on that array. So what happens in this case? Does it work because the account balances are numbers and we know how to compare them? Does it not work, but if we added a comparison method, or if we passed a comparison method to the sort method, then it would work? Do we say it doesn't work, but it would work if we define the spaceship operator for savings accounts? Or it doesn't work because since this isn't a basic Ruby type, there's no built-in way to compare them with the operator. So initial vote.